Weight, another word for it is force gravitational. So make sure you know that. Weight is force gravitational. And this is the force of gravity that is exerted on mass. Force of gravity. So if you have mass, guess what you also have? You exert a gravitational field. All right, what is mass? Mass is the amount of matter in an object. Okay, amount of matter in an object. So guess what? If you have more mass, you are going to have more gravitational force. Okay? How are weight and mass related? All right, so look here. There's a longer equation. Force gravitational equals G, big G, M1 times M2 divided by the distance between them squared. So this is why as you get further out from Earth, so if you get further away, so if you increase your distance, guess what? You are going to decrease your force gravitational by a factor of a square. Okay? If you increase your mass, you increase the mass of the planet Earth, you're going to increase your force gravitational. If you increase the mass of the object, like yourself, you're going to increase the force gravitational. Okay? But just know that this is the opposite here. If I decrease my distance, I'm going to increase my force gravitational by a square. It's an inverse square law. Okay? So here's how it works. Force weight, or I usually write it like that, force gravitational is mass times the acceleration due to gravity, which is 9.8 meters per second. I like to use in this class, and I'll let you know when, 10 meters per second squared. Okay, so this is important. This helps me grade real quickly and helps you kind of make estimations, okay? Helps you make quick estimations. This g right here, this little g, comes from combining these three values right here. So this right here ends up equaling little g, okay? So on different planets, you're going to get a different acceleration due to gravity. Like on Venus, you have about 5 meters per second squared. And on the moon, you have about 1.6 meters per second squared, right? So it's a little bit smaller. Okay, if you know the mass, you can find the weight, and if you know the weight, you can find the mass, right? So all I have to do is rearrange this equation. Force gravitational is mass times gravity, and I want to find the acceleration of the planet, I can just divide by m. So force over mass is equal to g, which is just acceleration. This is Newton's second law. Or I could have force divided by gravity, gravitational acceleration, to find the mass. Okay, so this is easy. I'll give you these equations. Okay, it allows you to convert between mass and weight easily. Okay, let's look at the next one. On another planet, your mass would be the same, but your weight would change depending on the amount of gravity. This is important because you can feel weightless, right? If you go really, 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 really high up, or if you go into the void, right? But you can still be crushed by a meteor, right? So it's important that even though you could lift that meteor pretty easily if you lifted it for enough time, the mass of that meteor, it still takes up space and it still has its effect on you, okay? Your weight would change depending on the gravity. On the moon, your weight would decrease, right? Your weight would decrease, and it would be about a sixth, 1/6 your weight on the Earth, because the moon's gravity is 1/6 that of Earth. A large bag of dog food could be carried easily with one arm. Just remember, if you get hit by it, though, it's still going to move you, right? It's still going to have an impulse on you. It's going to have momentum. So how do we calculate this? Okay, so what's the mass of a 2 kilogram, or what's the weight of a 2 kilogram mass? When you see weight, I need you to put force gravitational, because that's the equation there. And just remember that any force is related to acceleration and mass through this equation. It's just whatever this force is what gets plugged into here. So this is usually force net, but it can be force centripetal, it could be force friction, force air drag, and in this case, force gravitational. This is the exam question, folks. All right, so let's see how they do it. So you put the equation, right, after you've underlined everything, so it's mass, it's that, all right? You plug in 2 here, and your gravity on Earth is 9.8 meters per second squared, or 10, and this is what you get when you put it in the calculator. All right, last one. Do heavy things fall faster? No, they do not. They do not. Okay, and I'll show you the Neil Armstrong video. Okay, they fall at the same rate. All at the same rate. Yet you know that a hammer will fall faster than a feather. Well, on Earth it does, because the feather has air resistance. Okay, the feather has air resistance. And I'm just going to skip some. This is that forced drag, right, because of the surface area, the way it's spread out. All right, G is a constant on Earth, and if you're near Earth, this is for near Earth, it's 9.8 meters per second squared. You can also use 10 meters per second squared. And when I grade tests, you can use both answers, right? As you get further away from Earth, obviously, the field is going to decrease, and so is the acceleration. All right, the acceleration, or A, of all falling objects is the same. Okay, and you've seen this before when I showed the cannonball and the feather dropping. All right, guys, good luck.